recall what you learned from the recorded video for week 4, which is static force on a plane surface. 2.1.8, plane ataupun incline. Okay, so incline bila dia ada angle. Plane surface, it can be flat or flat vertically. Okay, so this is the force. So the learning outcome, you must be able to identify and also illustrate the force acting on a structure. Apply the pressure to solve the problem when the high force on plane surface. Okay, so you can see here the word pressure and force. So basically, the pressure dengan force adalah related. Dia punya konsep pun sama, dia punya force mesti perpendicular to the plane, to the structure. Okay, and we still use the basic formula for pressure. So pressure is equals to area, or force equals to pressure times area. So this is the basic formula that you should understand for pressure and force. Okay, so hopefully you already go through the important principles for the hydrostatic force. No shear stress, maksudnya fluid is not moving. The pressure exerted by a fluid under hydrostatic condition at any depth is equal. So this one, if you still remember, bila berada pada horizontal, the pressure sama. Okay, if the fluid is same, means the pressure is equal. Okay, this one is very important. The pressure or the forces is act perpendicular to the immersed surface or to the structure. Is linearly increase, maksudnya bila pressure increase, force increase. Already learn how to draw the pressure. So semakin dalam, semakin panjang arrow. So semakin panjang arrow maksudnya semakin tinggi pressure ataupun force. Okay, and then what you should know is about the pressure inside ataupun outside. Okay, so you can see here, we have the pressure from outside and from the inside. So outside is a pressure atmosphere and plus the gauge pressure, which is fluid pressure. This is that end. So let's see on this. Basically, this is a inclined plane. So you have the angle here. And this is symbol for water surface. For forces, it is important you know the free water surface sebab all the calculation must be calculated from above to below. Okay, dia berlainan dengan buoyancy. Buoyancy kita calculate daripada bottom to above. Untuk forces, we calculate from above to bottom. Okay, so this is the plane. Dekat plane ni akan ada center of gravity, G. Okay, length from water surface to the center of gravity, we call it as Hg. Length from the center of pressure from water surface, we call it as Hp. Okay, so this is the plane. Dekat plane ni akan ada center of gravity, G. Length from water surface to the center of gravity, we call it as Hg. Length from the center of pressure from water surface, we call it as Hp. Okay, so this is the plane. Dekat plane ni akan ada center of gravity, G. Length from the center of pressure from water surface, we call it as Hp. Okay, what is center of pressure? Center of pressure ialah point where the force exert. Okay, force akan jatuh ataupun akan act pada center of pressure. Okay, so you can see this one, the force is perpendicular to the plane. Okay, bersudut tepat kepada plane. Sama juga, if you have a vertical plane, force dia mesti perpendicular to the plane. If horizontal plane, the force must be perpendicular to the immersed object ataupun immersed structure. Okay, and then we also have the H. H ialah length from the water surface to the object. So basically untuk calculate something that bawah lagi daripada free water surface, kita akan kena tambah dengan nilai H. Okay, so this one is different from this one. Let's say for example, this is the free water surface. You ada this immersed object. Okay, so you boleh calculate saja terus dia punya nilai HP ataupun nilai HG. Is where there is a from the water surface. For example, it is like this, water surface. So dia punya immersed object dia jauh sikit. So this one you need to add with the H. So nilai HG adalah H plus HG. Okay, and nilai HP ialah H plus HP. Okay, another part that you should know, the center of pressure must be below center of gravity. Dia tak mungkin berada di atas center of gravity. Okay, so untuk this part ada soalan tak?
Tak ada doktor. Stakatnya okey.
Okay, tak ada. Okay, so this is the derivations of the formula. We need to integrate the resultant force, and this is the formula you might use for pressure related to force for incline and plane surface. So kita ada force equals to rho is density times gravity times area times the Hg. Okay, this resultant force F will act normal on a single point on the immersed object or immersed structure known as the center of pressure. Okay, must be the force ni mesti act dekat center of pressure. Okay, what is the area here? Area kat sini maksud dia ialah area containing fluid or area displaced fluid. Okay, maksudnya you ada real area ataupun imaginary area. Faham tak Pak ni? Okay, saya tunjuk examples lah. So you have one, Sekejap, let me show you this one. Maksud area containing fluid. Maksudnya you ada fluid. Okay, the first one maksud dia ialah area containing fluid ataupun surface, sebab kita guna kat sini surface kan, so surface containing fluid. So another one you have surface immersed fluid. Bukan immersed, displaced fluid. Okay, you have the same thing, tapi fluid dia dekat belah sini. Okay, so you have two area. The first one is the real area. Second one, we call it as imaginary area. Okay, the object or the structure or the surface untuk nombor 2 tu dia displace the fluid. Number 1, containing the fluid. So the area they boleh bagi you areas containing ataupun area immersed. Okay, later we go through the question yang real area ataupun imaginary area. Okay, so next, how we determine the center of pressure length, HP, length for center of pressure. Then this is the derivations of the formula. We integrate the formula of rho g hg area. Okay, so therefore this is the formula to find the HP. Okay, why we need to know the HP? Sebab kita nak tahu locations of the pressure. Okay, basically in the question they will ask you the magnitude, or sometimes they just use the word location. Okay, bila kita dah kira berapa banyak force, kita mesti nak tahu force tu kat mana. So HP is the location, berapa kedalaman force tu, berapa banyak, kat mana force tu act. Okay, so we use the IG. IG is a second moment area. This one will be given you in a table later. And then we have sines angle square. And then divided by area darab dengan HG. HG ialah vertical distance to the center of gravity. Okay, and the area pun sama. Area containing fluid or area displaced fluid. Okay, this second moment area ni depends on the shape of the surface ataupun shape of the structure. Okay, this is what I mean. So you need to calculate the area, and we also have the second moment area. Okay, for rectangle, we have B base times D. Dia punya length divided by 12, D cube. Okay, so we just need to follow this one. So untuk rectangle, it also can be used for square. Untuk triangle, it also can be used for cone. Okay, I hope that you already go through this one in the video. So, untuk this one ada soalan tak? So, kita ada front view, side view. So, you should be able to draw the force here. Force ni mesti perpendicular. Sebab ramai lagi yang tanya saya soalan. Untuk draw force ni mesti perpendicular to the plane. Ataupun to the structure. So, we have center of gravity. Center of gravity ni separuh daripada size of object. Sama juga our center of gravity ialah our pusat lah kan. So, untuk this one, center of gravity ialah 3 bahagi 2. Okay, so you get 1.5 kg. Okay, and then the HP, we need to use the formula. You cannot directly use kita tak boleh estimate lah. We need to use the formula. Okay, so the area ialah 2 times 3. Okay, and then we apply this formula, resultant force, rho G area Hg. Okay, 1000 darab 9.81 darab 6 and darab 1.5. So you get this as the force. And then to calculate the locations of the force, dah dapat nilai force, amount force, we need to know the magnitude or the location of the force. So we need to find the second moment area first. This one is rectangular. So we check back for rectangular. Okay, you can use BD or BH. Basically BH lah senang. High kan? D tu macam diameter. So you might get confused. So you can change to base times height cube. So we have the second moment area 4 meter to the power of 4. And then the angle is 90 sebab dia vertical, sudut tegak macam ni. Dia tak ada incline. So it is 90. Masukkan nilai into the formula of HP. And then we can have 2 meter from water surface. Okay, FFS ni from fluid surface. Okay, so you can check back if you want to make sure that your HP is correct. HP dia mesti lagi tinggi atau lagi besar daripada CG. So betul lah, CG 1.5, HG 1.5, HP higher than 1.5. So you have 2 meter from free surface. Okay, this one what I mentioned earlier, dia kena measure daripada free water surface. So for this one, untuk HG, you kena tambah dengan 2. Formula dia sama untuk HG, half of the structure size. So structure punya length ialah 3, bahagi 2 dapat 1.5. But we have the space here from the free water surface. So the HG need to add with the H. So 1.5 tambah 2. Then only you can have the HG. Okay, this one. Okay, area is still the same because the area is the area of the immersed fluid or area of the containing fluid. Okay, use the formula rho G area Hg. So this is the amount of the force, resultant force exert on the surface. And then find the location of the force. must be higher than CG. So CG ialah HG ialah 3.5, HP ialah 3.7. So correct. Okay, and then this another examples is different shape. So basically bila different shape pun you boleh nampak side view macam rectangular. So sometimes they provide you with the picture of side view. So you akan nampak macam rectangular. But in the question dia akan mention the shape. So check with the question juga sebab the picture must be front view ataupun side view. Okay. So bila bentuk dia circle, we use the formula pi r squared ataupun pi d squared over 4. DHG dia sama, half of the structure. So tinggi structure ni ialah 1.5, half of it ialah 0.75. Okay, after you get the amount of resultant force, you need to know the location of the force. We calculate the HP using the formula. So the HP is higher than 0.75. So correct. Okay, this one the same thing. You need to add the height from the water surface. Okay, dia boleh bagi nilai 3 ni ataupun dia bagi nilai yang atas ni, awak kena tambah nilai yang kat sini 7.5. Kat sini tadi 0.75 kan? So, the question can give you the length to the center of gravity, or you can calculate center of gravity plus the h. Okay, later you can go through the video again. Kalau ada soalan boleh tanya saya on this. Okay, so ada soalan tak?
Ya,
Okay.
ada doktor.
Okay, so previously example yang sebelum ni you learn on the immersed object. Okay, another part is related to gate. Okay, selain daripada immersed object yang tak ada tergantung ataupun apa-apa, kita boleh kira dia punya force juga. Another one is force for the gate. Okay, for example this question, kita ada inclined plane and kita ada gate. Okay, gate punya shape ialah rectangular. Dia dah bagi size 1 dengan 1.5. So 1 ni biasanya B lah. Base, this is H. Oh no, terbalik. H is 1. H ialah ketinggian gate B is 1.5. Okay, and then this is the H. We have HG and also HP. So the force must be act on the HP. Okay, why we need this angle? Sebab kita nak cari vertical height with the angle. Okay, so you can find the nilai X kat sini. Satu ni bahagi 2 sebab dia adalah center of gravity. So here is 0.5. Okay, using the 60 as the angle, you can find the value of X. So X ialah 0.433. Okay, and the HG need to add with the H, iaitu height from the water surface, and apply the resultant force formula. So the amount of force exert on the center of pressure ialah 35,802 kilonewton, and HP is to find the location where the force acts. So you can see here the Hg is less than HP. Okay, that is for rectangular gate. So the gate can be circle, rectangular, triangle. Okay. Okay, untuk triangle, bila triangle macam ni, dia punya center of gravity ialah 2/3. Okay, dekat bahagian bawah ni, 2/3. Kalau segitiga dia macam ni ialah 1/3. Okay, so kita ada center of gravity, center of pressure. Okay, so this one ialah 2/3. Tapi dia bagi you banyak nilai-nilai yang tak tahu. So we need to find the y and also the z, angle of 60. Okay, this one that I mentioned, the center of gravity ialah 2/3 times dia punya length of the gate ni. So 2/3 darab 4, you have 2.667. So the area ialah area of triangle, half times the base 4 and the height 4. Okay, substitute into the formula. So this is the force, amount of force, and then we need to find the location of the force. Use the formula, and the Ig here ialah untuk triangle. So jangan silap, dia sama je BH3, tapi untuk rectangular over 12, untuk triangle over 36. Okay, so there is a HP 2.9, Hg 2.6. Okay, so higher lah, betul lah tu. Okay, what is the difference of this question? First ialah nilai CG dia. This one is 1/3. Another one, they provide the whole here. So bila you calculate area, you need to minus the whole. Okay, Hg ialah 2 tambah 1/3 kali 3.464. The Hg 2 ni sebab jarak daripada water surface ni kena tambah dengan 2. Okay, so kita tak tahu nilai H. So we can use the formula of tangent. Angle is 60. Okay, and then the area is half times 4, dia punya base, length, times the height, tinggi, 3.464. Okay, untuk triangle ni, you kena tahulah angle dia. Dia bagi 60-60 ni maksudnya sisi sama. So, one triangle, dia punya angle adalah 120, 60. So, sini pun you dapat 60. Okay, and then use the formula to find the force. So you have, this is not the water. So density dia dapat 150 must be oil. Times gravity 9.81 times area and then times the Hg. Hg ialah 3.155. Dapat tak jawapan ni? Sama tak? Sama tak?
Dapat lain lah medium.
Sekejap 850 kali 9.81 kali 6.928 kali 3.155. 182261 kan? You betulkan lah. Okay, sometimes dia ada
Doktor.
betul kan 261?
Ya doktor.
Betul.
Okay.
261.
Betulkan lah. Okay, so dia ada dua elemen kat sini. Oh, area dia tak tolak dengan ni lagi lah. Oh, this one dia kira satu-satu dulu Dia kira elemen 1 ni, R1 ni ialah untuk triangle. And then below ni dia kira untuk circle. So area of circle ialah pi d squared over 4. Okay, and then this is the Hg untuk circle. Okay, macam mana dia dapat dua ni? Dua ni ialah yang atas. Dua ni yang atas ni. Lepas tu dia ada tambah nilai kat sini. 0.6. Okay, tinggi kat sini 0.6. This one, 0.6. And then, circle ni punya length ialah 1. Diameter dia 1. So, half of the 1. Okay, separuh daripada diameter of the circle tu ialah 1. 1/2 darab 1 dapat 0.5. So, you have the Hg untuk circle. Then, baru dia tolak. Okay, force dia tolak dengan space. Force for R1 minus force for R2. Okay, density dia sama, gravity sama, area 0.785. Ni ada darab dengan 3.1. Sama tak kira balik? 850 darab 9.81 darab 0.7 3.1 0291. Bolehlah perpuluhan tu might be different sikit, tak apa. Okay. And then second moment area pun ada dua. Sebab dia melibatkan two element which is triangle and circle. And this is for circle. Okay, and finally you can have the HP total, which is force R1 darab HR1 minus force for 2 and the height for 2. Okay, this is we calculate the average lah. Bagi dengan total of FRT, you have the HP total 3.397. Okay, so this one we have the trapezoidal. So to trapezoidal dia ada dua shape juga, melibatkan dua elemen, which is we have one rectangular and we have two triangle. Okay, dia melibatkan, so 1, 2, 3. We have dua triangle, satu rectangular. Okay, later you can go through this one, and the F total is F for first part plus second part plus the third force. Okay, boleh So you tengok kat sini dia punya force ialah perpendicular to the center of pressure kat sini. Sorry, sekejap. Okay, you have force total ni kat sini. Dia mesti perpendicular to the gate. So imaginary dia straight lah untuk gate ni. Vertical. Okay, sama juga the HP must be HP total. So you have three part tu. Force 1, force 2, force 3. Okay, and then we need to calculate the moment. You already learned the moment untuk solid juga kan? So moment, we assumption of moment equals to 0. So moment is force darab dengan perpendicular distance dia. Okay, 1.952 tolak dengan 1.1. So you have the perpendicular distance for the force minus the moment. Okay, so this is the perpendicular distance to the force tu. Satu 1.952 you dapat daripada nilai HP ni. Tolak dengan 1.1 yang bahagian atas ni. Kenapa tolak? Sebab dia nak cari perpendicular distance to the hinge. Okay, so ni hinge dia. Tak perlu sampai water surface. So jarak force sampai perpendicular distance to the hinge ialah 1.952 tolak 1.1. Okay, ni sama juga. They want you to determine the force required to keep the gate in a position. So we consider as moment juga, tapi dia tak cakap moment. Dia mention as the forces juga. So kita ada dua force kat sini. We have resultant force and the force to hold the gate. So we need to measure the perpendicular distance. So FR ni darab dengan perpendicular distance to the pivot. Pivot ni adalah dia punya center tadi. And the force darab dengan perpendicular distance to the pivot juga. Okay, HP ni you can use formula. HG also you can determine from this one. So 2. Tinggi gate ni ialah 4 meter. So HG ialah 2 tambah 2. Okay, so HG dia 4. The area nampak macam tegak kan? So you can check with the question. The gate is circular. Use the formula for circular, pi d square over 4. Okay, find the HP. Okay, and then we calculate the moment. Moment to hold the gate ataupun force to hold the gate. Force darab dengan perpendicular distance, which is here. Tambah dengan force darab dengan perpendicular distance to the pivot. Okay, and then substitute the resultant force so that we can find the moment or the force to hold the gate. Boleh eh? Okay. Let's try this one. Ada yang dah cuba tak? Anyone yang dah cuba this one? Okay, tak apa. Let's do this together. So, first thing, you need to know the length of the gate yang immersed in water. Okay, sebab 6 meter ni total length of the gate. So, kita nak cari nilai gate yang tenggelam sahaja. So, you have X. Here is 3.5. Here is 60. So, what is the X? Berapa nilai X? Faris. Arif Ali. Berapa nilai X tu? Still dengar suara saya?
Dengar doktor.
Berapa X?
Tengah kira doktor.
Okey, terkira dulu.
Saya dapat 4.04 doktor.
Bagus. Siapa? Najmi, good. So, you already know the X. X ialah 4.04. So, can you know the area now?
Boleh.
Sebab dah tahu nilai gate yang tenggelam. So, you already know the width of the gate, 3. So, area ialah 4.04 darab 3. What is the area?
$12.12.
Okay, good. 12.12. And then, you can find the HG, right? Berapa HG? HG ialah half length. Half vertical length of the gate. So, vertical length dia 3.5 kan? Vertical length here. So, HG ialah half of the vertical length, 3.5. Tak perlu tambah H sebab dia tak ada free water surface tu. Dia terus gate je ada. Tak ada above border. So, berapa HG?
1.75.
1.75. Okay, you follow the step je. Okay, dah dapat HG, boleh tak cari force? Semua dah ada kan? So, you can find the force. Rho G, HG area. So, masukkan semua value that you calculated already. Berapa force? Berapa?
208.070.
208 point
0.70.
070 kilonewton Okay, and then you can get the HP. HP, this one is a rectangular gate lah, tak mention pun, tapi basically rectangular kalau tak mention. So, the second moment area ialah BH. IG ialah BH cube over 12. So, high ni ialah high of the gate. So, base ni ialah 3 lah. White dia 3 darab 4.04 cube bahagi 12. So, the IG ialah 16.48 meter power of 4. So, you can calculate the HP using the formula. So, calculate the HP now. (16.48) times sin 60. Sin 60 square divided by 1.75 darab 12.12 tambah 1.75. Berapa nilai HP? Iman, berapa Iman?
Ya, betul. Saya tidur.
Okey, Abidah. Abidah dah kira dah? Puteri ke? Syed Irfan?
Bukan 82. Betul. Betul.
Orang lain? Tak dekat dah, tapi lari sikit. Ada jawapan lain tak? 16.48 darab sin 60 square bagi 1.75 darab 12.12 baru tambah dengan 1.75. Apa? So, 16.48. Dapat tak? Mana yang lain ni?
Satu poin 82.
Tak dengar apa?
Dapat 1.82.
Kenapa lain lah jawapan awak ni?
Doktor,
Ha.
saya dapat 2.439.
Lari sikit tapi nak dekat dah, Najmi. Okey, awak kira yang saya tulis 16.48. Darab dengan tulis sin 60 square. Bahagi HG ialah 1.75 darab 12.12. Baru dah kira yang ni, baru tambah dengan 1.75. Dapat berapa?
2.333
betul ke?
doktor.
Aduh,
Ha? Tak dengar. Semula?
3.53. Bukan.
Jauh. Salah.
Jauh.
Jauh. Ambil. Tadi saya dengar tadi. Najmi kot. Berapa Najmi?
2.333.
Yes. Very good. Thank you.
Oh, okay.
So, the
Saya
HP ialah
salah,
2. Salah apa?
saya salah masukkan nilai yang pertama tu, saya masuk 19.48.
16 BH.
16.
Okay. Sebab BH cube over 12 ni ialah 16.48. Okay. So, 2.33. HP ialah 2.33. Okay. So, bila dah dapat 2.33 tu, hopefully you can draw lah kat mana force dia. So, kat mana resultant force? Resultant force tu ialah perpendicular to the gate. Dia mesti kat dalam air. So, force dia kat sini. Perpendicular kan? So, this is the FR. So, 2.33 ni ialah length kat sini. Tinggi daripada water surface sampai force ialah 2.33. Okay, and then Q tu sebenarnya moment. Dia nak cari moment untuk hold the gate. Okay, so basically force ni mesti perpendicular. So, force dia adalah sebenarnya macam ni. Okay, tapi kita boleh je calculate Q ni. Tapi basically soalan ni silap lah sebenarnya. Tapi dia akan dapat jawapan lain kalau dia tanya force macam tu. Okay. So, let's calculate the original Q. Actual Q yang sebenarnya adalah macam ni. Okay. Perpendicular distance. So, perpendicular distance dia masih sampai ke hinge. So, hinge kat sini. So, macam nak cari Q ni? Q darab dengan berapa perpendicular distance for the force Q? Ni perpendicular distance dia 6. Okay, another force ialah FR. What is distance to FR? So kat sini perpendicular distance to FR. Nak cari nilai kat sini. You dah ada tinggi gate ni tadi kan? tinggi gate ni adalah 4.04. Betul. So tinggi sampai sini ada 2.33. Boleh tak dapat nilai kat sini? Boleh tak bahagikan 4.04 tu berapa nilai atas dia? Macam nak kira? Angle dia 60. Nampak tak yang saya lukis ni? Saya lukis semula lah, kok dia tak nampak jelas. Okay, kita ambil segitiga ni. So, dia macam ni. Macam ni, macam ni. Kat sini ialah 4.04. So, you ada length separuh from this. Ini 3.5. Sini 2.33. Here is 60. So, kita boleh cari nilai here. Yang kat sini. Yang apa nilai orange ni? .33 bahagi, kita namakan dia Y lah. So, Y equals to 2.33 bahagi sin 60. So, berapa nilai Y? 2.33 bahagi sin.
2.69.
So, yang orange ni adalah 2.69. Yang kita nak cari ni adalah yang bawah ni, X. Sebab perpendicular distance of the force ialah X yang ni. So, total length dia 4.04. Jadi, 4.04 tolak dengan 2.69. Dapatlah nilai perpendicular distance for FR. So, masukkan nilai FR.
1.35.
Yes, good. 1.35. So, boleh dapat tak Q? Dah masukkan nilai FR, then only you can have the moment Q. Force to hold the gate. Berapa? Dapat lebih kurang 46 jugalah. Dapat tak? 46 something. Tak dapat lah 747 ni rasanya. Lari sikit. Berapa dapat Q? Berapa? Yes, betul. Good. Good. Thank you. Betul. So dapat 46.815 kilonewton. Okey lah. Okey. Dapat So boleh tukar sikit soalan tu, nilai Q dia dekat perpendicular distance. Maksud saya perpendicular to the plane tu. Okay, so nilai Q dia kat sini. Kalau you nak dapatkan Q yang ni, dia jadi sama juga moment goes to 0. So Q ni adalah Q sin 60 darab dengan 6 perpendicular distance sama dengan FR darab dengan sama je 1.35 tadi. Okay, beza dia adalah nilai Q ni awak kena sin 60. Sebab direction dia berubah. So, you get the Q is lari sikit lah daripada jawapan. Q dia adalah 54.08. Okay, ni kalau Q dia macam ni dalam soalan. Moment yang Q yang sebenar to hold the gate adalah perpendicular to the gate actually. So dia ada error from that question. Okay, I still need to continue a little bit on the hydrostatic force. Later kita akan go through the examples for the curved surface ni, tapi kita tengok dulu formula dia. Okay, you can try exercise for inclined plane ni from tutorial or past year question. Okay, let's see next topic 2.1.9, the hydrostatic thrust or force or pressure on the curved surface. So basically, the immersed curved surface is subjected to water pressure as shown in a given figure. So semua pressure dia perpendicular to the immersed curve. Okay, semakin dalam, semakin panjang arrow means semakin tinggi forces. You can see lah. Kat sini small arrow. Here is larger arrow. So this means that we have larger forces. Okay, so for curve, how we calculate, we need to recalling forces as a vector. So it depends on which angle is given. So we have cos or sine. Okay, after kita dah vectorkan force, kita ada Fx in x direction, this one. And we have Fy in y direction. So we can calculate the resultant force, Fr, is Fx square plus Fy square square root. Okay, so selain daripada represent as x and y direction, kita boleh juga represent as Fh ni ialah force horizontal, Fh. Fy ni adalah force vertical. Okay, let's say on this curve kan, contoh tadi. You have this curve. This is like a semicircle. This is the hinge, water surface. Okay. So we have the horizontal and also the vertical force. So horizontal force dia perpendicular to the structure. So this is the Fh and This is the vertical force, FV. Okay, so kalau you all imagine, kita ada circle, bila kita pandang daripada horizontal, actually you tak nampak pun dia punya curve. Okay, so horizontal punya area, basically you akan nampak flat gate. Okay, the purple color ni untuk area for horizontal. Bila vertical ni baru kita akan nampak the curve. So, untuk vertical, dia punya force ialah suku circle tambah dengan atas ni. Boleh tak? Faham tak maksud saya? Maksudnya your view. Bila you pandang daripada side view, you akan nampak flat je, tak ada circle. So the area ialah tinggi gate darab dengan wide. From vertical view, you akan nampak ada curve which is 1/4 daripada circle ni. Ke atas sampai free water surface. So this is your area. This is area for
Keluar dah tak ada kelas dah. Keluar.